This section is 7-1 and 7-2, properties of exponents. I'm starting out here with this definitions, and I'm not going to stay on this sheet long enough for you to write this all down, or maybe I will, I don't know. I'm making this up as I go along. But this is pretty much the whole section right here. This is your notes for this section. I'm going to show you some examples of how this works, but this is all of the rules for properties of exponents. Now, these are things that you may have seen before. Some of them may be new to you. You may not be able to understand. I always had trouble when I was going through school understanding this format where it says a to the m times a to the n. So I'll give you some practical examples of what that actually looks like. So our first example here, a product of powers, a to the m times a to the n equals a to the m plus n. This is a practical example of what that looks like. Let's say if we had 5 to the 4th plus 5, or I'm sorry, times, that should be times, 5 squared equals, well, this is 5 to the 4 plus 2, which is 5 to the 6th. That's how that product of powers rule works. Now the next one, power of a power, a to the m times n equals a to the m times, or actually a to the m to the n power, the quantity to the n power equals a to the m times n. This is what this one looks like. If we had 5 to the 4th raised to the 2nd power, 5 to the 4th squared, this is 5 to the 4 times 2, which is 5 to the 8. You see how it's different from our previous example. And the third one is power of a product here, which is ab to the m power is a to the m times b to the m. So this is what that one looks like. If we had 5x to the 3rd power, that is 5 to the 3rd power, x to the 3rd power, which 5 to the 3rd power is 125, so it's 125x cubed. Whoops. X cubed is what we're going to get from that one. That's power of a product. So the next one is quotient of powers. Quotient of powers, so now we're dividing, a to the m over a to the p equals a to the m minus p. So what that means is if we have 5 to the 3rd over 5 squared, this is 5 to the 3 minus 2, which is 5 to the 1. 5 to the 1 is 5, we know that. Okay, so now the next one. So our next one is power of a quotient. Power of the quotient gives us a over b, so this is a fraction, a divided by b, all to the m power. This comes out as a to the m over b to the m. So this is what this looks like if I would have x over y to the 4th power. X over y to the 4th power. This is x to the 4th over y to the 4th. The next one is our zero exponent. This is the one that's really easy. A to the 0 equals 1. Anything that you take to the 0 power is 1. That's just how we define it. So we could have x to the 0 equals 1, or we could have x to the 5th to the 0 power equals 1, or we could have x squared y to the 3rd to the 0 power. Since it's to the 0 power, it equals 1. Doesn't matter. Anything to the 0 power is 1. That one you should never, ever forget. And the last one, negative exponents. A to the negative n equals 1 over a to the n. And also, 1 over a to the negative n equals a to the n. So that's, for instance, if we would have x to the negative 4, this equals 1 over x to the 4. Or if we would have q, or I'm sorry, let's do this. 1 over q to the negative 1, this is going to be q to the 1, which is q. Or if we have, let's go up here, if we have 1 over q to the negative 5, this is q to the 5. When you have a negative power, you just flip it the opposite side of the fraction bar. So let's work a couple examples. Actually, before we start our first examples, we need to have a couple of definitions. These are definitions here. First, a monomial. We're going to talk about, in this chapter, we're going to be talking about monomials and polynomials. If you just look at your roots, mon, or mono, is one, and poly is many. So a monomial is a number, variable, or a product of a number and one or more variables with non-negative integer exponents. So I'll give you an example of a monomial. An example of a monomial is x. That's an example. X to the fourth. That's an example of a monomial. Or h squared q to the fifth. That's a monomial. Some things that are not monomials are x plus 1. When you have the plus or the minus in between there, you have multiple terms, so it's not a monomial anymore. X squared plus 2x plus 1, that is not a monomial, that's a polynomial. Or another example of something that is not a monomial would be 7 plus r. You know, just anything that has a plus or a minus in between. I didn't give you any minus examples, so here's one with a minus. X squared minus 4, that is not a monomial. Those are polynomials. Also, we have constants. A constant is a monomial that is a real number. So anytime that you have just a number, that number is a monomial, like 5 or 12 or whatever. So here's a few examples, and this is on page 391 in your book. The first example is 10. Is 10 a monomial? Well, 10 is a monomial because it's a constant. The next one, f plus 24. Is f plus 24 a monomial? No, it is not a monomial because it is a polynomial. The plus tells you that it is not a monomial. It has more than one term. Monomials only have one term. Or they're they could be the product. The product, like this one right here, is a product. The product of a number and one or more variables with non-negative integer exponents. The next one is h squared. H squared is a monomial. It's the product of variables. And the last one is j, or you can even say 4j. It just has j in your book, but I think this is more helpful. 4j is a monomial because it's the product of a number and one or more variables. 4j is a monomial. Now we're going to do a couple examples. The first one is for product of powers. This is 6n cubed times 2n to the 7th. So I know with product of powers, a to the m times a to the p equals a to the m plus 3 plus p. I'm just going to add them together. So I know that I can multiply 6 times 2. That's easy. That's 12. And then I have this n to the third times n to the 7. Well, I know I'm going to add those exponents. 3 plus 7 is 10, so I'm just going to put 12n to the 3 plus 7, and then I'm going to simplify that to 12n to the 10th. Here's the next problem. This still uses product of powers. I have 3 pt cubed times p cubed t to the 4th power. Well, I have a 3 over here. I don't have any numbers over on this side, so I know I just put down my 3. So my p's, I've got p to the 1 times p to the 3. That's p to the 1 plus 3. And then I'm going to have my t's. I've got t to the 3rd times t to the 4th, which is t to the 3 plus 4. And this is the same as 3p. Well, 1 plus 3 is 4, so it's p to the 4th. T to the 3 plus 4 is 7. T to the 7th. 3p to the 4th, t to the 7th. The next property is power of a power. This is the example on page 393 of your book. Here we have 2 to the 3rd power, to the 2nd power, to the 4th power. So it's really power of a power of a power. We know that we're going to do this with this rule. A to the m times p equals, actually I said it wrong, a to the m to the p power equals a to the m times p. I mean, I'm telling you the answer right off the bat, just the way that I'm reading the question. So this is going to be the same as 2 to the 3rd times 2 times 4. Those are multiply. 2 to the 3 times 2 times 4. Well, 3 times 2 is 6. 6 times 4 is 24, so it's 2 to the 24th power. That is a big, big number, 2 to the 24th. So the next one is power of a product. With our power of product rule, we have AB to the m power is a to the m power, b to the m power. So we're going to distribute, basically we're distributing this fifth power all throughout every individual part of this. So I'm going to take negative 2 to the fifth power times x to the fifth power times, well, it's y to the third to the fifth power, so that is going to use our power of a power rule, which is to multiply the exponents, so it's y to the 3 times 5. So let's see, negative 2 to the fifth power is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and since it's an odd exponent, when you multiply a negative an odd number of times, it's negative, so that's negative 32. Then we got x to the fifth, we can't do anything more with that, and y to the 3 times 5, well 3 times 5 is 15, so it's y to the 15th. So our answer is negative 32, x to the fifth, y to the 15th. So this is our quotient of powers rule. This is now on page number 398. We've got g cubed h to the fifth over g h squared. With our quotient of powers rule, a to the m over a to the p equals a to the m minus p. We're going to be subtracting the exponents. So let's take a look at it over here. I got my g's here. So on top I've got g to the third, or g cubed. On the bottom I've got g to the 1, so it's g to the 3 minus 1. And my h's, I've got h to the 5 minus 2. And I should put those in parentheses so you really tell what that is. 3 minus 1 is 2, so g squared. 5 minus 2 is 3, h cubed. That is how my quotient of powers rule works. Next example on page 399 uses our power of a quotient rule, where we know a over b to the m power equals a to the m over b to the m. So I'm going to take all this junk over here, 3p cubed over 7, all to the second power. So this is the way that I'm going to do that. I'm going to take 3 squared and then p cubed squared over 7 squared. So 3 squared is 9. I know my power of a power, so I'm going to multiply 3 times 2, so it's p to the 6th over 7 squared is 49. The next one uses our zero exponent property. Anything raised to the 0 power is 1. So we've got x to the 5th, y to the 0. So this is the same as x to the 5th times 1 over x to the 3rd. So this is the same as x to the 5th over x to the 3rd. And now we can use our quotient of powers to get x to the 5 minus 3, which is x squared. So now our last example, yay, last example. Our last example uses our negative exponent property. When you have a to the negative n, that's the same as 1 over a to the n. So basically what I'm going to tell you to do is just flip it to the other side of the bar. Just remember that when you flip something to the other side of the fraction bar, it is multiplying. All of these things are always going to be multiplying, because 5 r to the negative 3 t to the 4th. This is 5 times r to the negative 3 times t to the 4th. So I'm going to show you how to do this so you can separate the terms to see exactly what's going on here with all this big gobbledygook. I think this is the way that you should write it out. If you have a different way, that's fine, as long as it works for you. So I'm going to separate the numbers. So I've got 5 over negative 20 times r to the negative 3 over r squared times t to the 4th over t to the 7th times 1, because we don't have any u in the top, 1 over u to the negative 5. Okay, now I'm going to use my negative exponent property. I'm going to keep 5 over negative 20 times, and now this negative 3 I'm going to put in the bottom. So I'm just going to have a 1 left at the top, and it's going to be r to the 3 times r to the 2. Well, I know with my product of powers, it's r to the 3 plus 2, which is r to the 5th. I've got 5 r's underneath now. Times, well, I'm still going to keep my t to the 4 over t to the 7th, but I know that that's going to change with my quotient of powers property. Times, I've got a negative 5 right here, so I'm going to stick it in the top, u to the 5th over 1. Okay, now 5 over negative 20 is negative 1/4 times 1 over r to the 5th times, well, now I'm going to do t to the 4 minus 7. So I'm going to get all the t's in the top. Well, here, take a look at this. When I have t to the 4th, I've got t times t times t times t. T to the 7th is t times t times t times t times t times t times t. That's a lot of t's. And so if I'm going to cancel out like I can with any fraction, and this is different from over here, I can cancel out with any fraction. So that cancels, that cancels, that cancels, and that cancels. So I've got 1, 2, 3 t's left in the bottom. So it's 1 over t to the 3rd times u to the 5th over 1. Okay, and then finally, I'm going to put them all back together. So it's going to be negative because I've got my negative right here. On the top, I've got a 1, which I don't care about, a 1, which I don't care about, a 1, which I don't care about, and a u to the 5th. So I've got u to the 5th on the top. On the bottom, I've got 4, r to the 5th, t to the 3rd, and a 1 I don't care about because anything times 1 is itself. So I've got negative u to the 5th over 4 r to the 5th t to the 3rd, and that is my answer. And it's a big, ugly answer, but that's just the way that it is. That's the most that I can simplify that problem.